Each session will be of around 35 to 45 minutes, followed by a round of question and answers. Our first speaker for today's seminar is Mr. SUNIL Mehta, General Manager of Technical Factory Automation and Industrial Division in Mitsubishi Electric Private Limited. He is the Chairman of CC Link Partner Association, India. Mr. Mehta has developed PLC-based solutions for printing, plastic, textiles and other industries. He is also actively involved in the development of numerous automation solutions like facility improvement using Mitsubishi products for various Japanese automotive clients like Maruti Suzuki, Honda Cars and others. Mr. Mehta is an active speaker on e-factory and Industry 4.0 nationwide. Mr. Mehta is an active sportsman. He plays table tennis. I invite upon Mr. Mehta to deliver the session.
Good morning. Thank you very much for my introduction. First of all, let me correct. I am not a doctor, I am not a PhD. I am a simple engineer. I did my engineering in 1989 and I joined a company called Business System where we used to develop the PLC, programmable logic controllers. I am sure that everybody is aware of PLC. And Mitsubishi took over in year 2012. Since then, I am working for Mitsubishi Electric India. And in today's situation, I am working as a business development for automotive industry. So that's my profile. And plus, I am also heading the CC Link, that's the industrial network. I am heading the CLPA as an association. Today, I will take you through the, first of all, few of my slides. I will discuss or I will talk about IoT, Industry 4.0, what exactly it is. So after first 10 slides, my presentation is focused on e-factory. E-factory is a terminology or coined by Japanese people. As you may be aware that Industry 4.0 is a terminology coined by the Germans. So in a similar way, in US, in China, in Japan, the smart manufacturing is recognized in a different way. What do you think? You want me to do this way? This is okay. So, maybe after my presentation, I have one video. That's a video for our factory in Japan, which is an e-factory, how it is implemented in Japan. It's been displayed over there. And after that video, maybe we can have a question and answer session. So my presentation will be roughly take 20 to 25 minutes, followed by 5 minutes video. And after that, we can have a discussion. Basically, I am an engineer and I have worked in the industry for almost 29 years. So that's the experience what we are carrying, and I'm also happy to get connect with the students after so many years. So because usually we travel for our business purpose, and usually we interact with the industry and not with the students. So this has given me a good opportunity to interact with the students. So I'm really thankful for the college and of course Shubham, who has took initiative to call me over here. Now this is the first slide what talks about Industry 4.0. This is a revolution of a modern factory or digitization. So everybody knows that the first industrial revolution, then there was the second industrial revolution which happened somewhere in, it was before 1900 centuries. At that time it was basically electrical power is used in the second industrial revolution. The third industrial revolution came somewhere in 1980 or 19, where actually the PLCs, the servos, the VFDs, there are various factory automation products are being used for the industrial revolution or the mass manufacturing. So the third industrial revolution was somewhere in these things before 20,000, and today we are talking about fourth industrial revolution. So this is the fourth industrial revolution, or we say industry 4.0. It's the same thing. It's based on the cyber physical system. So it's manufacturing expecting the fourth industrial revolution, which is the current rate of automation and data exchange in the manufacturing technology or in the manufacturing context. It includes cyber physical system, IoT, Internet of Things, and cloud. Now these are the lot of words has been used nowadays. We say that smart manufacturing. We have got smartphones. Today we are talking about smart cities. So this is basically a plane. So what is a smart factory? Now there are many words have been used. So people talk about big data. People talk about IoT, IIoT. So all these things are finally, and from Mitsubishi point of view, we call it as an e-factory. So our terminology from Japan side, we call it as an e-factory. So it's the same thing. We talk about smart manufacturing. So anybody can not make a definition of a smart. What is the definition of smart? If we start discussing about that, everybody can have their own views and different angle to say something about smartness. It could be the usage of the products. It could be the smartness in the living. So many things are there. So today we are talking about smart. Today we are talking about smart manufacturing. And also we are talking about smart cities, where we are going to improve our infrastructure as far as the transportation, water, power and all these things. So that's a smart city. So in the similar context, when we say smart factory, it's a digital factory. Now, what is the IoT? This, typically everybody knows IoT, Internet of Things. So what is it? It is a network of physical objects or things. It's a network of physical objects or things like vehicle, home, appliances and other items embedded with electronics, software, sensors, connectivity which enables these things to collect and exchange the data. Simple example of IoT, today I use Ola. It's an IoT. It's an IoT application. If I have a freeze or I have a smart devices where the communication is already established, say there is a water purification purifier from Eureka Falls. If it has got a built-in connectivity to the service provider, so when that particular product is going to get malfunction, if that information goes to the service provider well in advance, so the things can be more simple or things can be more smart. Today we talk about air conditionings of various companies are talking about air conditioning which can be made on using the smartphones. So that's again a home appliances which are connected with the built-in electronics or softwares or embedded systems which can communicate. IoT has evolved from the convergence of technologies like wireless. Wireless is one of the areas. I'm sure that you must be doing the Zigbee technology. But then what happens is that the wireless has got a limited bandwidth. And when we talk about the industry or when we talk about the machines, it generates a huge data. For any automotive industry, like a manufacturing industry like Suzuki or Toyota or Honda or two-wheeler companies like Bajaj and TVS and HMSI, where you use the Activas and all these things. The shop floor has got so many machines which produces the component. Now when that machine is made on, when the operator comes in the morning, the first shift, say at 6:45, he starts the machine and that machine works for say one shift for 8 hours. How much products has been produced by that machine is the data available inside the PLC. How much energy is consumed by that machine is the data available inside the PLC. How much time the machine was in manual mode, auto mode, semi-automatic mode, it was malfunction, it was down. So all this information is available in the PLC and this information needs to be transported. So there we talk about the networks or the communication. Now benefits of IoT: to monitor overall business processes, improve the customer experience, enhance productivity, integrate and adopt new business models, better business decisions, save time and money, and generate more revenue. So that's the benefit of IoT, what we talk about. Now, how IoT works. So basically, there are 4 stages how it works. So we have got sensors or actuators. I'm sure that everybody knows the sensors, like temperature sensors, vibration sensors, vision systems, RFIDs. So these are all sensors which are used in the industry for sensing or picking up the information or the pressures and all these things. So these are all sensors. So sensors or actuators can be wired or wireless. Then we talk about internet gateways or data acquisition systems, where we have the controllers like PLCs and HMI, the VFDs, servos and robotics. Then we talk about edge computing. So today people are talking about edge analysis or edge computing. So that's again an IT layer. So stage 3 and stage 4 is basically an IT layer, and whereas stage 1 and stage 2 is purely a hardware platform. So we have got networks and we have got controllers and the sensors which lie in stage 1 and stage 2. And stage 3 and stage 4 is purely related with the data analysis and IT systems. Now, IoT life cycle. So basically, we collect, as I already briefed you, we communicate, analyze, and act. So that's the life cycle of IoT. So within the collect, as I told you, that manufacturing plant, a lot of data is there, at offices, a lot of data is there, in vehicles, at home. So this data needs to be collected. So that's a collect, that's the first stage. Then communicate. Communicate could be using a wireless, using an internet, or using a networks, industrial networks. There are various industrial networks available in the market. When we talk about Mitsubishi, we talk about the CC-Link and CC-Link-I, that's an industrial Ethernet network. Then there is another from Germans, the Siemens talks about Profinet. Also Ethernet IP, EtherCAT, these are the networks which are the industrial networks available in the market. So these networks are used for the communication purpose. So sending the data and events through networks to some destination. The destination could be a server within the premises, or the destination could be the cloud which is outside the premises of the company. Then analyze. Once the data is gathered, it needs to be analyzed. There is a huge data. So what is the relevant data? What is the useful data? And on the basis of that, it needs to be analyzed. And then there is a visualization. Visualization means there are some screens or the GUI, there are some graphics where it can be represented. It could be bar graphs, it could be some charts, or it could be some reports. So that's the visualization. And then building the reports. And based on the analysis and all these things, the action needs to be taken again. And that needs to be feedback to the down there with the shop floor. So communicate with other machines, send notifications, maybe SMS or email or something like that, and talk to other systems. That could be in any application. Now this is the structure of IoT. So we have got sensing layer at the bottom. So we have got various control devices. There are various devices in general terms. These are the embedded controllers, or it could be a PLCs. So these are the controllers. Then the controller to the server. Then we have the network. So it could be TCP/IP network, VPN and telecommunication networks. And then we have application core, where actually the IP or the application layer is there, on which various application runs and they analyze the data. So that's the basic structure of IoT. So there are various applications of IoT. In industry, IoT has already become very popular, or maybe for smart manufacturing, IoT and IoT has been quite widely used. Agricultural automation is also becoming more and more popular nowadays. In fact, Mahindra and Mahindra and John Deere, these are the people who manufacture the tractors. Those are also becoming more and more intelligent because they work in the field and they have to get connected. Maybe the diesel gets over, the diesel is almost, the level is down now. Or maybe there is some over temperature of the engine and all these things. So the tractor can communicate with the service provider. So that's the again application of an IoT. So the IoT will play a lot of role in different areas, including the building management. Of course, in the building management, we have got so many security, we have got water, we have got power, the vision system, the cameras, everything is again IoT. Vehicle, as I told you, that asset, person and all these things, so all these areas will have an IoT. We use Ola, we use Uber, it's an IoT application. Of course, in energy consumption and in manufacturing, all the manufacturing areas, IoT is playing a very, very important role. Now, what challenges the IoT is facing? So, we're talking about scalability, technological standardizations, interoperability. There is a huge software complexity when you talk about the data and data analysis, data volumes and interpretations, power supplies, interactions and communications. Today, of course, we have internet, but still our systems has to be improved. Because we talk about any application or you talk about the data, again it depends upon the service provider and how that network or the communication is fast and reliable. That is important. And then wireless communication, which can be used within the premises of a factory. But still wireless is not becoming so popular, but it will take some time to have a wireless become popular in the industry also. In the industry we have a lot of Ethernet wireless devices available, so on which at a distance the data can be transferred. Wireless communication is used in the crane applications also, but then the safety is very important. So that needs to be taken care by the mechanicals or electrical things. So if the communication stops, then what will happen? So that's very important. So there is a wireless communication also will. So these are all challenges what IoT is facing. Now this is one of the Cisco stores. I just pick up the slide from that. So Internet of Things. So there will be individual networks. So we have home, we have got education, transport, business, energy, and these are all networks. And those networks need to be again connected to each other. So these connected networks with added security, analytics and management capabilities will allow IoT to become even more powerful in what it can help to people achieve. So that's the basic slide says about. So we have got different networks for transport, business, energy and all these things, and they need to be again interconnected to each other. The industrial IoT. So when we say IIoT, it's industrial IoT. So the industrial Internet of Things is the industrial or manufacturing. Basically, in the manufacturing, IoT is becoming more and more popular for the smart manufacturing. So manufacturing version of the Internet of Things. Industrial Internet of Things can be viewed as a systematic expansion of automation and progressive improvement of how machines communicate each other at the manufacturing sector. See, during my college days, PLCs was not so popular. Of course, PLCs were used, so 1980s or something like that, people used to have ZDD based or 80 based microcontrollers. So that was that area gone. Then you people, when you are now in your curriculum, you have got PLCs and you have got variable frequency drives and robotics and servo, AC servo systems and all these things. Now, moving ahead, IoT will also become more popular. Even in academia also, the people are also going ahead with the IoT as a curriculum, maybe for 1 year or maybe for one 6 months. This is IoT is also becoming popular in the institutes also. That's what I understand. So industrial IoT is basically an IoT used in a manufacturing context, and automation is becoming more and more powerful. And automation, the PLCs can communicate with each other. That's the industrial Internet of Things. Now this is just an IoT and IIoT. What exactly the objectives are? So when we say IoT, the focus is on individual consumer. When I say industrial IoT, so that is a ROI. In any industry, people talk about return on investment. So that's the basic terminology used. So whenever there is a manufacturing company or whenever there is a plant which manufactures some goods, when we do some investment for say IoT or IIoT, what would be the benefit that the owner or the manufacturer will get? So return on investment is very important. So that is improving the efficiency, safety and productivity. Basically in India, a lot of components are getting manufactured and now are getting exported to countries like Europe also. In fact, if you see the TVS in Mysore and Bangalore, near Bangalore, they are manufacturing the motorcycles as a brand of BMW. So, and they are going it back to Germany. Same way Bajaj is also in Jharkhand, they are manufacturing KTM. So we are talking about the good quality products to be produced and exported to the other countries. So we are trying to become more and more quality cautious, as well as we are economical, so we can sell our components outside India. So there, the productivity and the IoT plays a very, very important role. So whenever there is the people from Germany or people from other countries or Japan will come, they will see the shop floor. They will see the processes, how the manufacturing processes, how the products which are manufactured, the quality is good, and how the supply is reliable. So that is very, very important in the industry. So IIoT gives efficiency, safety and productivity, because it gives a complete visibility of the shop floor. What is happening on the shop floor, that information can be made available to the management at a simple way, in a very simple way. Now systematic breakdown, so if IoT is do not create an emergency situation, then if we talk about IoT, it can generate an emergency situation, mission critical, even if the machine is down or something like that, it will have a huge impact on the production. There is a huge loss of the production. Driving philosophy for IoT is human productivity. In IIoT, it is a machine productivity. Then there are various applications which I have listed down. Major drivers of IoT, so industrial IoT, so cloud computing, big data analysis, intelligent machines and standardization of processes. Again, benefits and challenges of the IIoT. In case of benefits, we talk about safety, security, reliability and efficiency. Again, there are not many challenges because we need to identify the things, manage massive data, then integration of existing infrastructure into new IIoT. That is very important because we have got various plants which are working for 20 years or 25 years. So those equipments or those machines are equipped with the old controllers, and those old controllers cannot communicate. Or there are many dedicated microcontroller based systems has been used in the manufacturing. So those cannot communicate on the standard protocols. So that's the challenge what we will be facing, because we have not many industries where the machines are working for 20-25 years and they are not able to communicate, or the protocols or the informations are not available. So that puts a challenge while communicating these equipments. Power of cloud computing and enabling short-term data storage. So these are the challenges as far as the IoT is considered. I'll just talk about e-factory. From Mitsubishi point of view or from Japan side, we always talk smart manufacturing as an e-factory. It's the same word we can say Industry 4.0 or smart manufacturing or digitization. So all these things finally is one and the same thing. We are talking about connectivity of the sensor to the ERP level. The ERP could be SAP or something like that, and the data from the sensor is connected through the controllers to the network, to the MES or the upper ERP level. So that's the smart or digitalization of the factory. Now this slide talks about, if you see 1970s, mainframes, ERP, internet ERP models, MES, etc. And at the bottom level, you can see that direct digital control, the remote IOs, that the PLCs and 1990s, we talk about field bus protocols. As I talk about some of the protocols, like Profinet or Modbus, these are the protocols. CC-Link is the protocol by Mitsubishi. So CC-Link IE, that's an industrial Ethernet, or maybe Ethernet IP or EtherCAT. So these are all protocols. So these came into picture, the field bus protocols and DCP, and then there is an integrated architecture which got evolved somewhere in 2000. And if you see this today, 5-layer architecture of this particular pyramid, at the bottom we have the IOs, then the PLCs, SCADA, I'm sure you know, is the software supervisor control and data systems. Then MES, that's again a software product, manufacturing execution system. And then we talk about the ERP. ERP could be SAP or something like that. And in the future, the edge computing is also coming into picture, and artificial AI and these things are also will play a very important role in the manufacturing as well as the smart manufacturing industry. And at the bottom, I have shown the devices. So we have got walls, which can be smart walls or IoT walls. Then we have got Fitbit or something like that watches. Then Google Glass, RFIDs, smartphones and everything. So everything is going to get interlinked to each other, and it is going to get interlinked to the machines also. So where information, meet the factory of the future, where information technology, that is IT, and operational technology, that is OT, this is the conversion. Now this is as far as the manufacturing. In the manufacturing context, we talk about vertical and horizontal integration of the systems, of the processes. So we have got sales, we have got development, and we have got stock plannings and all these things. So everything is going to be interlinked. So there is a horizontal value chain networking and a vertical value chain networking. This I spoke about. So we talk about the three elements of a factory. Data collection, that's the sensing. So we talk about the sensors, actuators, vibration sensor, temperatures, pressures. So all these things are the sensors, and those sensors are usually connected to the PLCs or the controllers. And data communication technology, so where device-to-device communication and high-speed communication. So we talk about our network, say we talk about CCLink IE, that is the industrial Ethernet, which works at 1 gigabyte. So we work at 10 Mbps, 100 Mbps or 1 gigabyte. And that highways are already laid. And the last is the data analysis technology, which is the IT layer. So we talk about simulation, statistical models, artificial intelligence. So this is purely related with the IT technology. So an ICT-driven world enables this process to be faster and more efficient. Now today's industrial expectations. So we talk about factory of the future, where we want to talk about standardization work process, connected, seamless data flow. So all these things are required, and e-factory can deliver this particular things. So comprehensive solution for all future needs, that's e-factory. Go ahead. Now this is a pyramid. In this pyramid, at the bottom layer we have got all the field devices, and the field layer, the machines, CNC machines, robotics, PLC controller machines. So all these machines are there, the energy meters and all these things. So at the bottom level we have got a complete production. At the middle layer there is a controllers. So these are all the PLCs and the HMIs and all these things with the MES interface and everything. And then at the top level there is an MES and ERP system. So that's an IT layer. So these are the products which are available from Mitsubishi point of view. So we are at the bottom level, we have got all these products available. So we have got the push buttons, remote IOs, energy meters, safety devices. There is one more sensor which we have brought in, that is vibration monitor sensor. So this sensor has been developed along with in Mitsubishi, Germany, and Schaeffler, that's an FAG company. So we have developed this IoT vibration sensor. See, for any induction motor, there are three important parameters. One is the temperature, current of the windings, and the vibration. So all these three parameters can be monitored by this sensor, which is specially developed by Schaeffler and Mitsubishi Electric. So this we can say a smart sensor or an IoT sensor. So this gets connected on Ethernet or particular protocol to the PLC, and we can monitor the status of the motor, which is working on the shop floor. You can find a number of induction motors working on, and in various applications like conveyors or the paint shops. So all these things, there are induction motors. So we need to monitor the healthiness of those motors. So this gives the priority or predictive maintenance data. At the control layer, we have got so many PLCs and all these things, and we talk about these networks. So we talk about OPC technology. We talk about CCLink IE, that is an industrial Ethernet network, which is by Mitsubishi, but it's open network, like a Profinet as well as this other Ethernet IP. These are all open networks. So the people can develop the product which are compatible to this network. So suppose somebody is a temperature controller manufacturer using a PID algorithms and all these things. That temperature controller can have various communication protocols can be embedded into that particular controller, so that it can be compatible to the CCLink IE or maybe Modbus or maybe Profinet as and when required. And then we talk about IT layer. We have got SCADA systems, we have got HMIs. This is an industrial PC, and we are talking about H-Cross. So that's again a software algorithm, software developed by Mitsubishi based on this rail IPC, which is now the technology is going into that direction. So this is our experience and journey. So if you talk about e-factory official release in Japan, year 2003, and the first mention of IoT as a concept is year 2000. So in Japan, we talk about e-factory, official paper release was done in year 2003. What we did, we implemented this e-factory in our factories in Japan, in Nagoya, which is the mother factory where we produce PLCs and motors and everything. Almost 9,000 employees work over there. So there we have implemented our own e-factory. If you see first mention of Industry 4.0 is year 2001. Sicily IE, the first industrial 1 gigabyte network technology was released in year 2007. So if you see that technology-wise, Mitsubishi or Japan, we are well advanced. Then we have implemented e-factory in Fukuyama works, where we manufacture the meters and everything. We also implemented e-factory in China in year 2013. And in India, we have done many e-factory solutions in pharmaceutical as well as automotive industries. If you talk about Suzuki Motor Gujarat, Maruti Suzuki in Gurgaon as well as Manesar, we have implemented so many e-factory solutions. So basically we have integrated their equipments to the ERP level. So that's the e-factory, or that's the digitalization of our smart manufacturing. These are the partners for partnership. We work on the partnership because from Mitsubishi point of view, we have developed so many partners. In the IT side, we have got like IBM. IBM is one of our partners. So SAP is one of our partners at the top level. So these are the various partners. At the bottom level, we have got various sensors and actuators. I don't know whether you have heard about Festo or SMC. These are all pneumatic products. So these are all our partners as far as this e-factory is considered. Then there are RFID manufacturers like TERT or maybe Balof. So these are all people who manufacture RFID readers and controllers. Then in the vision, we have got Cognex. They make the vision cameras for the inspection purpose. So those are all integrated to a network, and this is how the systems work. So there is a field level, control level, and a business processes. So at this, I would like to conclude. So I have tried to inform you about IoT, IIoT, e-factory, or maybe Industry 4.0, and what is a smart manufacturing. I will just quickly run through a video which is for our mother factory in Japan.
Connected to the internet. Most of you. By 2020, 50 billion devices are expected to be connected to the internet. Most of these devices will be built into industrial equipment. The huge amount of data derived from these devices is about to revolutionize manufacturing. The advanced connection of production equipment with the information network achieves a future-oriented factory. Established over 90 years ago, Mitsubishi Electric Nagoya Works is the production center of FA products. Starting with general-purpose electric motor production in 1924, we have made progress with the global manufacturing industry through the development and production of FA equipment, including sequencers and numerically controlled equipment. Meanwhile, Nagoya Works actively promoted network standardization by developing and releasing CC-Link as an open industrial network. As an FA total supplier, Nagoya Works has offered various FA products and developed solutions to visualize and solve latent issues at work sites and increase productivity. In 2003, the E-Factory concept was announced. Nagoya Works started to innovate manufacturing by utilizing IT. E-Factory is a solution for creating intelligent factories by connecting manufacturing sites with cyberspace based on optimal methods in order to further promote the utilization of cyberspace in manufacturing. E-Factory establishes a seamless link between the production site and the IT system. Production, equipment operation, and quality information is collected real-time, while the analysis results are fed back to the production site. This optimal environment enables workers to quickly practice an improvement cycle based on the worksite situation and data. This is how E-Factory creates a future-oriented factory. The model factory is the E4 factory, the new FA equipment production building. Optimization of production. In the surface mount process for electronic parts, the situation is visualized and analyzed on a real-time basis. Defects are quickly detected to ensure high quality and productivity. Optimization of manual work. E-Factory links products with equipment and makes it possible to give accurate work instructions. The quality and productivity of manual work are enhanced. Collaboration between workers and robots. The E4 factory achieves collaboration between workers and robots. This robot assembly cell is also connected with the network. The operation information is stored in the database on a real-time basis to ensure traceability management. Optimization of the value chain and supply chain. E-Factory also helps optimize the value chain beyond worksite improvement. Analysis of the work history data helps improve on-site work and identify issues throughout the product life cycle, including design change. E-Factory also helps optimize the entire supply chain. The seamless connection of the supply chain achieves flexible production in response to changes in market demand. Sustainability. The E4 factory achieves energy conservation through E-Factory and increases sustainability. Energy conservation has been achieved by employing an energy-efficient building structure. Our energy-efficient equipment and sequencer-operated autonomous lighting and air conditioning control systems. Power consumption has been cut by about 30%. E-Factory ensures flexibility to meet changes, sustainability, and vitality at the worksite, and helps increase customer satisfaction. E-Factory offers a reliable solution to on-site issues, increases corporate value, and achieves future-oriented management.
hope this video has given you more idea or insight about it. Honestly speaking, I am not here to sell Mitsubishi products. I'm not here to talk about something like an e-factory. Of course, we have my parent company or the company I work for is Mitsubishi Electric India. And whatever knowledge or whatever experience we have gathered in industry, my purpose of coming over is to share that knowledge with you. And if you have any questions, or first of all, I'm not a doctor, I'm not a PhD person. I'm a simple engineer, and I still work as an engineer. So even though after 29 years I feel to be proud to be an engineer, and I want you people also to work very hard for our country, for your family or for your parents, but then work ethically, and a lot of opportunities you guys are having today, because we're talking about so many things and the fields are becoming so and so diversified. So you will have lot many opportunities to work in various environment or various industries, but wherever you work ethically and have a nice time with your family. Thank you for your attention. If any questions are there, I would like to take maybe a few questions. I'm okay with that, or otherwise I can interact with you. That's not a problem. Yes.
Yeah, good morning. It was really very insightful talk which you gave, and we understood how the e-factory or Industry 4.4 is going on all about. I have two questions. In one of your slides, you have shown that edge computing and smartness at the IT level. So I would like to understand the level at which currently the edge computing is done and the AI is used to take decision, the current scenario, and what are the future prospects for all of us here, maybe researchers, students, so that they can think innovatively in that direction. Thank you.
Actually, from Mitsubishi point of view, we have already came out with the Edge Cross as a software based on our industrial PC. So Edge Cross technology is already in the market. From our side, from Japan side, it has not been launched in India, but it is being launched in other countries like US and Germany and Japan. So H-Cross is already there, and we formed an H-Cross consortium, which was announced in November 2017 in Japan, in worldwide. So we already have, and there are many people like IBM, Oracle, Mitsubishi Electric, so they form an H-Cross consortium. And H-Cross software is being developed by Nagoya. So basically what is happening is that, suppose I have a factory in Shirur, another factory in Dahanu. I'm talking about one of the pharmaceutical companies where we are looking upon. So where a lot of data is generated by the machine, the capsule manufacturing machine. It's not like that all the data has to go to the server, which is based in Mumbai, maybe in Kanjuli or somewhere else. Now, if we have an H-Cross over there in a plant, what will happen is that H-Cross will take some decisions at the local level itself. In the H-Cross, we also have some analytical or some software tools where we can filter out the data on the conditions, and that data the relevant data can then further pass on to the server for further analysis. So definitely H-Cross and this technology is going to come in a year or two in India. Of course, our other competitors and other people are also working in that direction only. So H-Cross is definitely going to come. As far as AI is concerned, I'm sure that a lot of artificial intelligence will go in the manufacturing conditions. It is already happening. People are working on that, augmented reality as well as AI. These will have a lot of future in the manufacturing and in other areas also. Mitsubishi, I have another presentation which is purely talk about AI, what we are bringing in from the technology point of view. If you say AI is already available, it is already there. When we say an autopilot, it's an AI, it's an artificial. Even in Japan, what they do is that in Japan, the health of the driver and the health of the vehicle. So everything is combined by the software. And based on that, the vehicle can take a decision. The driver pattern, if the driver is driving for say 10 days and it is entirely his clock or maybe his heart rate, BP, everything is recorded. In addition to that, the vehicle healthiness with the pressure in the tires and everything is recorded. And based on that, decisions can be taken, or predictive decisions can be taken so that the accidents can be avoided. So AI is going to play a big role in all our incoming years. Maybe another next 2 years, a lot of activities will happen on AI. And AI will play a big role in manufacturing industry also, definitely.
Thank you.
No questions from the students, so I don't know whether it has been understood or it has been. Because I am sure that you are all instrumentation or electronics and telecom engineering, because I did my ENDC from MIT.
Sir, I would like to know that you brief us about MES. How MES and ERP, you said that they at IT level they help us to they help system to communicate with each other.
Right.
I would like to know how they help.
Actually, MES is a manufacturing execution system, is a software which is above shop floor or in between ERP. See, what happens is that SAP was usually used by the manufacturing companies mainly for the planning and so many financials and CRM and all these things. And at that time, SAP was not communicating with the shop floors. But today, and there was an in-between layer that is called as either SCADA or an MES. It depends upon the companies whether they want to implement MES or not. Now in Chakan, it has been implemented by Mahindra and Mahindra. In Tata Motors Sanand, where they manufacture the Nano and all these things, MES is implemented. So MES is a package which syncs between ERP and the manufacturing processes. And MES can take a dynamic decisions which initially our SAP or ERP system does not used to take. But now the line is again getting thin. ERP as well as MES, those are all getting merged. SAP has came out with their products which can act as an MES. Now where it is required? On the shop floor you have got 10 machines. Out of that, one machine goes down. So definitely your production, the entire further chain is going to get affected. Because out of 10, 9 machines are now producing the products. And one machine is down say for 1 hour. So those many products have been produced less. In old days, SAP or the ERP does not used to understand this. Whereas MES can take the quick decisions and they can reschedule all these things. So that was possible. But now the SAP, the ERP level is also, they are also getting close to the shop floor or manufacturing processes. So the connectivity of the controllers like PLCs to SAP is directly possible nowadays. Okay, so MES packages are also there. They are already in the various production sites. So MES is already being used. And MES then connects, throws the data to the ERP system and takes the plannings and all these things from the ERP system. So in the morning, suppose I say that I want to make 400 two-wheelers today, active one. Then maybe 300 DO or something like that. So that entire data comes from ERP, that is the SAP, to MES package. And from MES package, it goes to the shop floor.
Hello sir, my name is Manish and I am from Trade Engineers Private Limited. We basically manufacture machines for the automotive industry, and I think told that you look after the Suzuki, Motor, Gujarat, and what development is going on. So I also work as a business development, and as I move across industries, we came across companies or industries which are demanding solutions combined with IoT, smart manufacturing, and Industry 4.0, as I said. Yesterday only we were discussing about these things, the demand from customers coming from like energy management, Industry 4.0, and how these processes, real-time data can be monitored so that how efficiently they can monitor the processes. So I wanted to know that for companies like Suzuki, Motor, Gujarat and all, they have their own IoT infra.